We're going to go through a handful of properties of logarithms. The first property to know is if you take the logarithm of 1, it doesn't matter what the base is, the log of 1 is always going to equal 0. One of the reasons this is, if I have any generic base there, I'm just going to call it b, when I switch over to exponential form with this b tunneling under here, I'm going to end up with 1 equal to b to the power of 0. And no matter what number you have to the power of 0, it equals 1. Another way to think of this property is logarithms and exponential functions are inverses of each other. So if you remember finding inverses, we took our x's and y's and we swapped them. So anything to the 0 power equals 1. So the log of 1 is always equal to 0. Running through these very quickly, log base 7 of 1, well, that's 0. Log base 2 of 1, that is 0. Log, this happens to be base 10 of 1, will equal 0. And natural log happens to be base e of 1 is equal to 0. So the first takeaway is a logarithm of 1 always equals 0. The next property we're going to go through is what happens when the bases are matching. So if our bases are matching, what I mean by that, the name of this is a base. Now if I completely cover this up for a second and I have the light blue to the purple, like for example 5 to the power of 2, this is the base and that's the exponent. So vocabulary wise, this is a base and this is a base. When the bases match, then everything disappears and all I have is the exponent. In this one here, this is the base and all of this is up in the exponent. But if my bases match, all of that goes away and I just have that for an answer. So we're looking for matching bases. Sometimes those matching bases are not obvious. Like this one right here. If I see that I have the log base 5, I need to force that 1/5 to be 5 to the power of something. If I make this 5 to the power of, like, 1 over 5 is 5 to the power of -1. I now have rewritten 1/5 as 5 to the -1 to force those bases to match, so my answer ends up being just -1. Let's try that again. In this one, if my base is 2 and I want to do this by hand, then I need to rewrite the number 32 so that it is 2 to the power of something. So thinking about 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so that is 2 to the 5th power. I force the bases to match, that disappears, and my answer is 5. Okay, let's look at a few more examples here. I have log of 100. I don't see the base on the log, so that tells me that this happens to be base 10. I want to rewrite the number 100 so that it is 10 to the power of something. So rewriting the number 100 so that it is 10. 10 squared is 100. So I have 10 squared. Notice those matching bases that I forced. The 10s, that all disappears, and my answer is 2. All right, this one, the base is 8. So I need to rewrite 1 over 64 as 8 to the power of something. Let's start off by just saying, well, what is 64? 64 is 8 times 8, 8 squared. Now that I have this look, hopefully it's a little easier to see. How could I rewrite this as 8 to the power of? Since 2 is in the bottom, I'm going to end up with 8 to the power of -2. So I've rewritten 1 over 64 as 8 to the -2, forcing those bases to match. So my answer in this one is going to be -2. Okay, last example here. I want to rewrite the number 27 so that it is 3 to the power of something, forcing the bases to match. So 3 times 3 times 3 is 27, so this is 3 to the third. I forced matching bases, so my answer is 3.